Okay, so today we want to go over the standard operating procedures of graphing, the do's and don'ts of graphing. So right now we have gone over various different functions. We should recognize when we have a line, when we have an absolute value V shaped, when we have the sideways curve, and we should recognize when it's going to be a parabola. So we should know when things are squared. When you have something that is squared, it's going to give you a parabola. So the fact that this is squared, we're going to have a U shaped, right? When we have the y equals mx plus b, we know we're having a line, and if it's positive slope, it's slanting in the positive direction. Negative slope slant in the negative directions. We should know when we have a vertical line and when we have a horizontal line. We should know when we have a V, and we should know when it's that sideways curvy thing, right? So those are some different functions that we should already kind of recognize. When I see an absolute value, I know I'm going to get a V. When I see a polynomial with the degree 2, I know it's going to give me that U parabola shape. We call that a parabola, and we should be able to recognize when we have our lines or our linears. Okay, when you are asked to graph, you must use graph paper. So on your homework, you have to use graph paper. So you either have to go purchase some, or you can print out some graph paper that we put in the modules. But you're not allowed to just make your own on a regular piece of paper. It's not acceptable. We'll mark you down points for not using graph paper. When you're building your coordinate plane, so this is the first one, when you have an x and y axis together, that's called a coordinate plane. When you're building your coordinate plane, you don't want to have a line in between the lines, right? You're not picking a line in between the lines. You're actually picking a line on the graph paper to use as the x and a line on the graph paper to use as the y. That's the purpose of having the graph paper, like you're missing the point. And then you have to decide what you're going to go by, the increments that you're going to go by. Most of the time we go by ones. So most of the time we want you to go by ones, unless you have really big numbers in your t-tables. Then you might want to go by twos or maybe by fives if you have really big numbers. Sometimes you need to go by halves. If you have a bunch of small numbers, then maybe you want to go by halves so that you can be more accurate. So in the first example, I'm going to go by ones. I'm not going to sit here and go 1, 2, 3, 4, because it gets squishy, right? So instead of doing that, we're going to go by ones. So we're going to go by ones, but we're not going to actually write every single one. So we're going to say this is 2, this is 4, because we know where 1 is and we know where 3 is, and this is 2 and this is 4, and then don't forget the negatives are going down. So right? Now, if you're going by ones and you don't label anything, so if you don't label anything, it's the assumption is you're going by ones. So if you don't put any labels in there and you start graphing, the assumption is that you are going by ones, right? If you're going to go by twos, then wouldn't this be 2, and this would be 4, and this would be 6, and this would be 8, -2, -4, -6, -8, +2, +4, etc. +2, +4, right? -4, right? So if you're going by twos, then because you wouldn't want to write 2, 4, 6, 8, it gets really squishy, right? So understanding how you're labeling your paper, that's important. The other important thing is when you're labeling it, don't put the labels in the box. So don't go 1, 2, 3. The labels don't go in the box. The labels go on the lines. So again, if we're going by ones, it would be 1, 2, 3, 4. Notice how I'm putting the 2 and the 4 like right on top of the line. -2, -4, etc. -2, -4, +2, +4. So it's right on top of the lines. Okay, so there's that. When you're building your coordinate plane, you don't have to darken in these marks, right? Don't waste your time. That's a waste of time. Sometimes we do it only to help you emphasize, so you're seeing because we're doing a video, but that gets really busy on the eye. So that's the whole purpose of having graph paper, is you don't need to do that. So you don't need to darken those in. It just kind of makes it harder on the eyes. So you do not need to do that. We recommend that you don't do that, right? And you don't have to necessarily, you should always label at least a few. And again, if you're not labeling it, we're assuming you're going by ones. This drives, I think, every math teacher nuts. People who add the extra tick marks. You're kind of like, do you realize why we have graph paper? We have graph paper for accuracy because we have the vertical lines and the horizontal lines that are nice and straight. This is not being very accurate when you start adding a bunch of tick marks. So it's not acceptable. We will not allow it. Okay, you are allowed to adjust your axis. I don't know if everybody knows that. Sometimes when we're graphing something, the graph is way up in the top of the first and second coordinate quadrants. So sometimes we want to lower our y-axis to give us more room, right? To give us more room up in the upper two quadrants, quadrant 2 and quadrant 1. Sometimes we want to lower our axis or move our y-axis. So I'm just letting you know that that's okay to do. So when you're looking at your t-table and you're like, wow, this parabola has been shifted down 3 and it's opening down. So maybe I'll move my x-axis way up on top further and my y-axis below because I know most of my graph is going to be down here, right? And that is called a sketch. And when we ask you to graph, we are not looking for a sketch. We're actually looking for a graph, so we won't allow a sketch. So you can move your axes in such a way to give you more room to graph that. So sometimes maybe we need more room over here, right? So I moved my y-axis further to the left because I knew my parabola was going to be way over here, so I gave myself more room. So I just want to let you know that you can do that, and you should be thinking of that when you're graphing. And again, if I do not mark anything, it's assumed I'm going by ones. If I'm not going by ones, then I have to tell the reader that I'm not going by ones by, something like that, so I know that you're going by twos. Next slide. Quadratics, so we're in chapter 2 now, and chapter 2 is working with quadratic functions. And quadratics are polynomials of degree 2. That is where the exponent is 2. And notice in examples 1, 2, and 3, we have all different styles of quadratics. So we have degree 2s. And quadratics will always graph as that U-shaped, which we call a parabola. Look at number 4. You might say, well, that's not a quadratic, that isn't squared. And I ask you, well, is it? Is number 4 a quadratic? But it just doesn't look like it right now because it's in a different format? I wonder what that would be. Things that are not acceptable. These are not acceptable graphs. So you have the first one. These are not V's. Parabolas are U-shaped. They are not a V. So if you give us a V, we're going to mark you wrong. Parabolas do not have it does not go straight across like that. So you should not have, it's not like a flat U. It's a nice, soft, curvy U, right? So it shouldn't have a little flat bottom there. No tulips. No tulips. It's not a half breed where it's half parabola or half absolute value and half parabola. So no half breeds in there. And no squigglies. We should be able to graph and do a nice soft U curve. And then the other thing is it has symmetry. So the other problem is that graphs have symmetry. So when you're drawing a graph, it's not okay to do like a hook, right? Parabolas have symmetry, so you should always show that symmetry of that parabola. Okay, so there's that. So these are not acceptable parabolas. When you are actually graphing, and we ask you to graph, there's a difference between a graph and a sketch. When we're asking you to graph, you have to do t-tables and their work next to the graph. So we don't want the t-tables on a separate piece of paper. We want to see it next to the graph. And so you can do it right on here. You are not allowed to sketch. This is an example of a sketch where we just kind of went, it went up 3. So I see that the parent graph was shifted up 3. So I'll just have my parabola shift up 3 and then I'll just draw a little U. Sketches are not okay when we ask you to graph. Sometimes sketches are appropriate in different times. But when we say graph, you must graph it accurately. So on this particular problem, we have our parent graph, and didn't we just move our parent graph up 3? So wouldn't that make the vertex 0, 3? And then from that vertex, we can, and you're going to learn more about actually how to graph in some of the other videos after this video. So they're going to show you that in different ones. But we could plug in numbers. So if I plugged in 1, then that would give me 1 squared plus 3, and that would give me 1 plus 3, and that would give me 4. So I could plot 1, 4. And then I could plug in 2 squared plus 3, and 2 squared is 4, 4 plus 3 is 7. And maybe I could plug in 3 squared plus 3, and that's 9 plus 3 is 12. And so this is my t-table work. And then I can plot 0, 3. So there's my vertex. And then I've got my other points to plot. I got 1, 4. I have 2, 7. I have 3, 12. And 3, 12 is a little bit off my paper, and that's okay. And then parabolas have symmetry. So there's a line of symmetry. In other words, if you were to fold this line along through the vertex, like if you folded the paper, the other points would show up on the opposite side the same distance. So since this is 1 unit from that line of symmetry, this one's going to be 1 unit from that line of symmetry. So since this point right here is 2, this point's going to be 2 because they're going to have symmetry. This point is 3 units away from the fold line, so the other point's going to be 3 units away from the fold line. So we're using what we call the axis of symmetry to graph the other points. And then once we have that, we can sketch it. Now this is where we want you to be more accurate. So sometimes I have to turn my paper. So right now I'm rotating my paper and I'm trying to get a really nice parabola, right? Trying to make it not super squiggly, right? Because we don't want any squiggly ones. So you might have to turn it sideways, and we're expecting some decent parabolas. So that's the expectation. And we should see the points that you plotted very obviously so that we can see you plotted it. And it's always important to state the vertex and any other missing and any other vocabulary information that they tell you in the other videos. So in the next few days, we will be going over how to graph in 3 different forms. We're going to be looking at vertex form, we're going to be looking at standard form, and we're going to be looking at intercept form. So the next 3 videos are going to talk about how to graph in those particular forms. Make sure your parabolas are good. Make sure you show your work next to your parabolas, and no unacceptable tulips or half-breeds or squigglies or V's or flat U's. Have a good day.